Hi everyone. If you've ever looked at a long chain of carbons and felt overwhelmed by how to name it, this video is for you. Today, we are breaking down the IUPAC rules for alkanes, the foundation of organic chemistry. By the end of this video, you'll be able to name even the most complex branch structures with confidence. Let's dive in. Alright, let's break down the anatomy of a chemical name. Every IUPAC name consists of three main parts. Think of it just like a person's name. You've got the prefix, the word root, and the suffix. First, let's look at the heart of the name, the word root. This tells us exactly how many carbons are in the main chain. You'll become very familiar with these prefixes: meth for 1 carbon, eth for 2, prop for 3, but for 4, and so on. Next, we have the suffix. Since we're focusing on alkanes today, the suffix is always going to be -an. This is your signal that the molecule contains only single bonds. Finally, we have the prefix. This part handles the extras. It tells us about the substituents, or the side chains, that are attached to that main carbon chain. When you put them all together, prefix, root, and suffix, you get a precise map of the entire molecule. Now, let's move on to rule number 1. You must identify the longest continuous carbon chain. In IUPAC naming, we call this your parent chain. Here is a key tip that trips up a lot of students. The chain doesn't have to be a perfectly straight line. It can bend, turn corners, or zigzag. As long as it's one continuous path of carbon atoms, it counts. But what happens if you find two different chains that are the exact same length? Here's the tiebreaker: you choose the chain that has the greater number of side chains, or substituents. Basically, the chain that is the most crowded is the winner. Once you've found that longest path, you've found the skeleton of your molecule. Now, let's see how to number it. Let's take a closer look at this example of 2-methylpentane to see exactly how numbering works in practice. Look at the two boxes on your screen. We have the left-to-right method and the right-to-left method. First, look at the box on the left. When we number starting from the left side, our methyl group, that CH3 branch, falls on carbon number 2. This gives us the name 2-methyl. Now, compare that to the box on the right. If we start numbering from the right side, that same methyl group doesn't show up until we reach carbon number 4. This would give us 4-methyl. In IUPAC naming, lower is always better. Because 2 is less than 4, the left-to-right numbering is the only correct way to do it. You can see the big red X over the right-hand box. That's a mistake you want to avoid. This all comes down to the lowest locant rule shown at the bottom. If you have multiple substituents, you must number the chain so the set of numbers or locants is the lowest possible when you compare them one by one. So, always count from the end that gets you to a branch the fastest. It's as simple as that. Now that we've numbered our chain, it's time for step 3, naming and alphabetizing. This is where we assemble all our pieces into one final IUPAC name. First, let's look at branch names. When an alkane becomes a side chain, we change its ending. So, ethane becomes an ethyl group, and methane becomes methyl. You can see in our alkyl group glossary that ethyl always comes before methyl when we alphabetize them. This brings us to the rules of assembly. Rule number 1. Alphabetical order. You must list your substituents alphabetically, like E for ethyl before M for methyl, regardless of what. But what if you have identical groups? If you see 2 methyl groups, we use the prefix D. If there are 3, it's tri, and 4 is tetra. Here's a pro tip. When you're alphabetizing, ignore prefixes like D or tri. You only care about the name of the group itself. However, you do include prefixes like iso or neo in your alphabetical count. Don't forget the punctuation. It's the grammar of chemistry. Use commas to separate numbers from other numbers, like 2, and use hyphens to separate numbers from letters, like 2-methyl. Host. Let's put it all together with this visual example. 3-ethyl 2,2-dimethylhexane. Notice how ethyl comes first because of the letter E, followed by dimethyl because we ignore the D and look at the M. We have a hyphen between the 3 and ethyl and commas between the two 2's. This gives us a perfectly structured IUPAC name. We've mastered the rules. Let's put everything together in step 4. Assembling a complex IUPAC name. We're going to name this specific molecule step by step. First, we find the parent chain. Looking at the skeleton, we count the longest continuous path of carbons. In this case, we have a main chain of 7 carbons. 7 carbons mean our word root is heptane. Next, we move to step 2. Number the chain. We have two options. If we start from the left, our first branch is at carbon number 2. If we start from the right, the first branch wouldn't be until carbon number 5. Since we always want the nearest branch, we choose the left to right numbering as our correct path. Now, step 3. Identify and locate the substituents. We see an ethyl group sitting at carbon 4. Then, we have two methyl groups, one at carbon 2 and another at carbon 3. Because we have two of them, we call them dimethyl. Finally, look at the final complex structure on the right. We assemble these pieces into the final IUPAC name. We list ethyl first because E comes before M alphabetically. We use a comma between the 2 and 3 and hyphens to separate all our numbers from our words. Put it all together and you get 4-ethyl-2,3-dimethylheptane. It looks long, but when you follow the steps, it's just like putting together a puzzle. Look at the general formula at the top left, CnH2n+2. This formula is our secret code for alkanes. It tells us exactly how many hydrogen atoms surround our carbon chain. Now, let's go down the list based on the number of carbons. If we have one carbon, the word root is meth, making it methane. For 2 carbons, it's eth, giving us ethane. 3 carbons use the root, prop, for propane, and 4 carbons use but for butane. As we move to 5 carbons, the root is pent, for pentane, and for 6 carbons, it's hex, for hexane. You can see the small chemical structures next to each name showing how the chain grows longer with every step. On the right side of the screen, you'll see the IUPAC naming conventions. Notice the pattern. We take that specific word root like meth, eth, or prop and simply add the suffix -an to the end. This root plus suffix combination is the foundation of every alkane name you will ever write. Keep this chart handy. Whether you are appearing for Class 11 exams or preparing for the GPAT, these 6 roots are the ones you will use most often. If you found this helpful, hit that like button and subscribe for more pharmacy and chemistry tutorials. See you in the next video. Happy learning chemistry with Harshada.